All right, listen. I've been out in Carrington since 2010. One of the things that I learned very early on is that, most growers were having a hard time getting consistent control out of fungicides against white mold and soybeans. And this was the case in our area and other parts of North America as well. And these are guys who could get good, decent control on dry beans. And so I set out to try to address this. The key on this is you really need to leave no stone unturned, if you will. Anyhow, what I'm going to present to you today are the results of about a decade of work. Okay, conducted in Carrington and Oaks primarily. We have an irrigated research site down in Oaks that's on irrigated sand, so pretty similar to what you have out in Minnesota. And then also some collaborative work up in Langdon, and even the irrigated research site out in Hoffman, which is east of Williston, which again is an irrigated sand. Anyway, so I'm going to present the results of that today. Those of you who have been to the International Crop Expo over the years will have seen bits and pieces of this, but not everything. All right, first of all, we're going to talk about fungicide timing. Okay? So what I want you to do is imagine you're in your soybean field, and it's R1. And you take a look at the canopy closure. In this case, what I call late R1. It was 60 to 85% of plants at R1. R1 is at least one open blossom, okay? And on the x-axis on this slide, you'll see what that canopy closure was at that time. And what we did is we managed all these trials to facilitate white mold. So if it wasn't raining, it got irrigated like heck. All right, so you can always irrigate wrong and get white mold, right? Well, that's what we get to do. All right, and so I made note of the canopy closure. I went out and sprayed that timing, okay, that treatment across all of my reps. And then we went out again at early R2. Early R2 was 80 to 98% of plants at R2. R2 is a case, in case you forget, is now you count nodes. So you go to the top of the plant, and the very top node with a fully unfolded trifoliate, that's your top node. If you have an open blossom on one of those top two nodes, you're at R2. Okay? So 80 to 98% of plants at R2 is early R2. So then we sprayed again then. What you see on this scatter plot is the yield gain or loss associated with waiting to early R2. And what I want you to note is this. Look at this. If that canopy was open, you'll almost always gain yield by waiting. If the canopy was closed, though, look at that. Right where we have 100% on the x-axis, well, a lot of the times, you did better by spraying at R1. Not always. What's the difference? Well, if the weather was just really non-conducive to white mold, even if you irrigate, if it's super hot, you're not going to get infection events. But, on balance, you're better off spraying at R1 if the canopy is closed at R1. Okay, and what you can see here is on the average yield gain, you can see that we went from a 3 bushel gain to a 5 bushel gain by waiting to early R2 on balance. Okay, on when the canopy was open. Now let's look at it when that canopy was closed. Right? There you are, slightly better yield by spraying at R1. Okay? So now we do the same comparison, but now we're comparing R1 to full R2. Full R2, in this case, I'm defining as 100% of plants at R2. And we did this just as soon as they hit 100% R2. Okay? This is just a day or two after, usually, early R2. And what you see here, again, if that canopy is open at R1, now we're looking at that yield gain or loss associated with waiting until full R2. What do you see? If that canopy is open as R1, you almost always gain yield. A couple times as a wash. Okay? And on balance, what? You went from a 3 bushel gain to, what? A 5 bushel again. Notice how you are more than increasing your return to your fungicide by more than 50% again? Okay? If the canopy was closed, though, at R1, and you waited till full R2, well, there you go again. If you happen to get hit by cool, wet weather, you got disease, and you got penalized for waiting. Yeah? All right, and so here we are with early R2 versus full R2. Okay, so now we're sitting on early R2, and here's the canopy closure early R2, and this is the yield gain or loss associated with waiting to spray to full R2. Okay, so if the canopy is open early R2, less than 100% of plants at R2, you always gain yield by waiting until full R2 to spray. But if the canopy was closed at early R2, more often than not, you lost yield by waiting. Yeah? And there you are, canopy closed at early R2. You better spray at early R2 if weather is favorable for whitewall. Okay? Now, the big giant question is, okay, I'm at full R2, but my canopy isn't closed. Should I spray? Or should I wait until the canopy closes, right? Because up till now, if the canopy has been open, you're supposed to wait, right? Well, we tried that. Okay, this was the canopy closure at full R2. That's the yield gain or loss associated with waiting till early R3. And what do you see? You're almost always losing yield by waiting till early R3, even though the canopy is open. Yeah? So, why is that? When you're at R1, you have very few dead blossoms. When you're at early R2, you also don't have a lot of dead blossoms. You have more than R1, but not a lot. Okay? The sclerotinia moves into the dead blossoms, right? So when you do not have a lot of windows for infection, the disease needs some help. If the canopy is closed, that's helping the disease, right? All right? It checks the airflow. If the canopy is closed, the airflow can't get through to dry out that canopy, right? And even though you don't have a lot of windows for infection, when that canopy is closed, it's enough. All right? And so if you're at a growth stage earlier than full R2, you spray if the canopy is closed or very close to closure and weather favors whitewall. But if that canopy is open, you can wait till full R2. Once you get to full R2 though, you're in full bloom, and those plants are loaded with dead blossoms. And basically what happens then is you have so many windows for infection that even if there's still ground between the rows, that you need to spray and protect your plants because there's so many avenues for infection that if you get some weather favorable for white bulb, you're going to get white bulb. Okay? And so again, spray it as soon as the soybeans reach 100% R2, unless your canopy closes earlier. And this is, of course, when you have conditions favorable for white bulb. Okay? Very good. Now we get to talk about the good stuff. Droplet size. Okay, so that was all hand boom studies. These are all tractor applied studies. Okay? And, the dotted line is you spray fungicides always with fine to medium droplets. And there's a good reason for that, right? Good reason for that dotted line. So, a 500 micron droplet, we're talking about a diameter here, right? Okay? And if you go down to 250 micron droplet, well, you're changing diameters, right? So, but we're actually talking volumes, and we're talking a number of droplets. And so you go from one 500 micron droplet, will give you 8 250 micron droplets, and you split that in half to 125 micron, you suddenly get 64 125 micron droplets, right? Now, fungicides do not move downward with a phloem. Your modern fungicides move upward with a xylem, and that's it. Okay, they never move downward. So imagine you get one of those 500 micron droplets on a leaf. Well, depending on how good that local systemic movement is, you're going to make it partway up the leaf with that product, with systemic movement, or all the way to the tip. Okay, even if it makes it all the way to the tip, the best case your scenario is you're getting 2/3 of that leaf protected, and the rest of it unprotected. All right? And now if you get that down to 8 droplets, wow! Now you have a good chance of getting pretty much that whole leaf protected, except notice that petiole is still going to be, in the very base of that leaf is still going to be unprotected, because these fungicides do not move downward, right? And then you go to that 64 droplets, woohoo! Now we got coverage. Now we got full protection. So this is why people recommend using fine to medium droplets with fungicides, okay? Very good reason for that, right? And when we use the old contact fungicides, some of you guys are sugar beet or potato growers and you still use some of those. Okay, and notice those don't move at all. They just protect whatever they hit. All right? But with local systemic movements, they can compensate. But now look at this. Those little tiny droplets. Doesn't matter what PSI you shoot them out at. They don't have any velocity because they don't weigh anything. So look at that pink line there. That's 58 PSI application pressure. And you can see that those little tiny droplets, it doesn't matter if you're shooting them out at 29 or 58 PSI, they're not hardly moving. They don't have any weight. Okay? And so you only get some velocity to the droplets if they weigh something. And shooting out at a higher pressure only helps you if they weigh something. All right, now, where does white mold develop? It doesn't develop on the top of the canopy, now does it? Okay, it develops on the bottom of the canopy. Last quarter, or bottom third to bottom quarter of the canopy. How the heck? If you're at R2, your soybeans are 24 to 28 inches tall, usually. And you might very well be very close to canopy closure, if not at canopy closure. How the heck are you going to get a tiny droplet that hardly has any velocity to get down to the bottom of the canopy? You need something big, that's heavy, with a lot of velocity, that's going to bounce around, it's going to splash once it hits, okay? And then you can actually get down the side. So we did our testing with Wilshire nozzles, okay? And T-jet nozzles. And we selected our droplet sizes just like a crop advisor or a grower would. We went to the catalog and said, okay, this is the PSI we need and this is the nozzle we need to hit a medium droplet. Okay? We did this all with flat fan nozzles. So extended range, extended the XR, T-jet nozzles, and then the Wilshire combo jets. All right, so this is our calibration process. Maybe it'll work today. All right, so we get these half-gallon milk jugs, really high tech. The person who does our finances actually chastised me. She said, you know you can't buy chocolate milk with grant funds and feed, your high school student crew. I'm like, well, no, that was just the cheapest half-gallon jugs. So anyhow, we put them up underneath our nozzles, okay? And now Jesse, who's manning the tractor there, he's going to jump in there and run it for exactly 10 seconds. Okay, and now you can hear it running. We have this equipped with a pulse width modulation system from Capstan Ag. And if you listen really closely, I'm being too loud, you can hear it pulsing. Okay? So then we take it off. And very, very high tech, we go and pull this out and measure how many mils we got, how many milliliters we got, okay? If there's a little bit too much, we adjust the pulse width accordingly to get it perfect. Okay, this is after we have chemical in the tank, so we do this as our last step before we spray. And we adjust that pulse width over and over again until we get it perfect, okay? So we're going on now. All right, so here's our tractor-based sprayer and our homemade boom that's just pointing to one side. And we're doing everything at 15 gallons an acre. Most of our spraying has been done at 9 to 10.5 miles an hour. But occasionally we get these bumpy fields, and this tractor has no suspension, and we don't like to break our back, so sometimes we go a little slower. These are huge studies because you need to do lots of reps to learn something with white mold, which is really spotty in its intensity. And we've always done this on lots of soybean varieties, some bushy, some upright, to get differences in canopy closure. Okay? All right. So next video shows the application process. Next slide. Okay, perfect. So here we are, and you can see we have these little flags out there with the numbers on them. Those are the treatment numbers. Of course, we got a map in the cab, but when you're spraying a 13-acre field like this, at 10.5 miles an hour, or this one's at 9 miles an hour, you can get lost. Okay? And he gets to the second flag, he's going to shut off. You can see there's a little transition zone there, so he can turn off the boom in peace without having to slam on the brakes. Next video. It's coming in the other direction. Now you can see, he comes up to the flags, he turns on the boom, and here we go. That's the whole treatment there. We're spraying 6 different varieties in a row. All right, you can see it pulsing. These are T-jet tests. Yeah? All right, perfect. So now we'll start talking results. Okay? So first off, I have these results broken out by the amount of canopy closure in the soybeans when we spray them, okay? And this test was done at Oaks and Carrington over 4 different years. And these are the soybeans that were wide open at 100% R2. All right? And on the very top, you see canopy closure. Average and then a range. Of course, there's always a range across the field, right? Same with us. And so average canopy closure here was anywhere from 64 to 73%. Okay? And you can see in 3 of these varieties, well, heck, there was so much variability over the field that there was no real result for the droplet size, okay? Our main source of variability was just a horrible stand. Okay, and well, in this case, some of those got hailed out early on. That's why we have bad stand. But anyhow, 1 year we didn't get good results. And what do you see there? Look at those yield data. We're optimizing response in that wide open canopy when we were applying with fine to medium droplets. That's what you're supposed to do, right? End of story, right? Right? Well, not really. Let's see, can we go forward? Doesn't want to go forward. There we go. All right. These are soybean varieties where our average canopy closure is between 80 and 89% at 100% R2 when we spray. Okay? And what you see is, look at those disease data. You see you're minimizing disease with a medium droplet, right in the middle of the medium spectrum. Okay? And on the yield data, if you look at every one of those studies, in each one of those studies, we had no statistical separation on yield, but every single time, the yield was maximized in that medium droplet right in the middle of the medium spectrum. Every single time. And in every one of those studies, it was the difference between making money on your fungicide and losing money. Okay, if you look at the average yield data, there you go. 5 bushel yield gain by using medium droplets. 2 bushel with fine and 2 bushel with coarse. That matters. And there you have statistical separation because I mean, every one of those studies is treated like a replicate, and you can see we saw that same thing in every study. So yeah, you have statistical separation. There's no accident when you see the same thing over and over again. Okay, next slide here. My clicker isn't working. I don't know if we're out of presentation mode or what. There we go. And here we go. These canopies were getting really close to closure. So we're anywhere from 92 to 96% average canopy closure. And where are we optimizing yield? Coarse droplets. Same with disease control. That is a big difference. Yeah? Next slide. I think we both hit it. There we go. And here the canopy is pretty much sealed up when we sprayed it. 100% R2. 98 to 100% canopy closure. And what do you see again? Optimizing disease control and yield with coarse droplets. And it makes a big difference. So we're going to look at these data in another way. What I've done here is the exact same data, but what we've presented them in as is the yield gain conferred by the fungicide. Every one of those dots is a result of one study. The bar is the average. Okay, so if the canopy was wide open, we optimized our control with fine, and the medium droplets were really close. Okay? Go to the medium droplets, look at that. The difference between a 1.7 bushel average gain and a 4.3 bushel gain. You're more than doubling the response to your fungicide by using that medium droplet. Then as the canopy is really close to closure, you go from 3.9 to what? Is that 7.2 bushels? That's huge. Almost doubling your response to your fungicide. And all you did was get your droplet size right relative to the canopy closure. And on the very, very close canopy, the same thing. 6.5 or 7.4 bushels, so if you have fine and medium droplets, and you go all the way up to 10.3 bushels, how much does that cost you? Like almost nothing. You might need another set of nozzles that you can use for many, many years if you take care of them. Yeah? And then you set your pressure right. That's all that's involved here. Okay? But notice something, your droplet size is calibrated relative to canopy characteristics. We did this testing with, let's see, we want to go forward. This doesn't seem to want to work for me again. Good. We're going to go on to Wunsch nozzles. This is just the summary size. You want to hit forward. Okay. So we did this testing with Wunsch nozzles too. And the reason is this. With those T-jet nozzles, as you change droplet size, you change your output, right? And so we kept our spray volume the same and our driving speed the same by changing pulse width. Okay? If you're doing good science, you're changing only one thing, not two. So we were changing droplet size and we were changing pulse width, right? So I don't consider that good science, but that was the best that we could do. All right? Wilger manufactures a lineup of tips that enables you to change droplet size without changing spray output. Yeah? They're a lot more expensive. You're paying like 3 times as much money for Wilger tips. They're better engineered, to be honest. Much better engineered than the T-jet tips. Their tolerances are a lot tighter. But they're much more expensive, so not many people use them. But from a scientist in me, geeky mode, they're much better because they allow me to now change just droplet size, not pulse width too. Okay? We do calibrate still to make sure everything's right. It allows you to figure out if you have any plugs in your nozzles, right? But anyhow, here we go. Open canopy. We only did this testing 2 years to location, so fewer data points. But listen, here we are. Open canopy. 63 to 79% average canopy closure. And what do you see? You're optimizing disease control and yield with coarse droplets. All right. What did we do with T-jet? You would have been fine to medium with T-jet there, right? There's a reason for this, and I'll get into it in just a second. But let's go on to the next slide. Okay, here we go. These canopies are closed. 95 to 100% canopy closure, well 99.6 average canopy closure. And you're optimizing disease control and yield with very coarse droplets. So notice something here, that we are seeing the same relationship. As the canopy gets more closed, you need to use coarser droplets. Okay? But the scale is shifted. We did spray card analyses to characterize the actual droplet sizes emitted, and indeed, what Wilger defines as very coarse is about the same as what T-jet defines as coarse. I was warned about this when I started this work. Okay, 2 minutes, perfect. I was warned about this when we started this work. There is no industry standard for how droplet size spectrum is defined. Within a company, you have consistency. But across companies, you have different definitions. So be aware that what Wilger considers coarse is not the same as what T-jet considers coarse. All right? And we've been doing this testing on other crops and other diseases, and we're seeing the same thing over and over. It's always this shift between the manufacturers. All right? And the big thing is that we're seeing the same relationship. As the canopy gets denser, you need to get your droplet size coarser. Now, let's think about this a little bit. This makes lots of sense. Whenever you have a coarser droplet size, you lose coverage. Okay? So you only want to get as coarse as you need to get into your target. Okay? If you can get into your target with a medium droplet on T-jet tips, use the medium. When you go to coarse, you lose coverage. Okay? And you want that coverage. All right? Now, if you can't get to your target with a medium droplet, it's not doing you any good. Right? So then you sacrifice a little coverage to actually get the product to where you need it. And because these are locally systemic fungicides, they can compensate to some degree for the lack of coverage. Be aware that if you are working with sugar beets or soybean or potatoes and are using some old contact products like chlorothalonil, for instance, well, that's a different ballgame. We can talk about that privately if you want to. We've been doing some testing with chlorothalonil on chickpeas. It's a different ballgame. That's a contact fungicide with no systemic activity. These locally systemic fungicides can compensate to some degree for a reduction in coverage. And this is what we're taking advantage here. Okay, thanks. That's all I'll cover here today. If you have questions, I'll be sticking around to the end of lunch. I don't know if we have time for a question or I've gone too long.
There's a few minutes for questions.
Okay.
If there are any.